Streaming Data Analytics, Exploring Popular Open Source Stream Processing Technologies. I'm Gary Stafford, AWS Principal Solutions Architect and member of AWS's Analytics, TFC, or Technical Field community. You can find me on LinkedIn, GitHub, Medium, Twitter, and YouTube at Gary Stafford. This video represents my viewpoints and not of my employer, Amazon Web Services, AWS. This video demonstration is based on a recent two-part blog post which I authored, Exploring Popular Open Source Stream Processing Technologies, a brief demonstration of Apache Spark Structured Streaming, Apache Kafka Streams or K-Streams, Apache Flink, Apache Pinot, and Apache Superset. The two-part blog post can be found at tinyurl.com/OSS-stream-processing. Agenda. First, we'll review some terminology used throughout the post and the video. Then, I'll discuss the environment that I'm using for the demonstration and for the video. Next, I'll let you know where you can find all the source code shown in the video and in the post. Next, I'll introduce you to the Streaming Data Generator project, which I am using to generate synthetic data for this post and the video. Then, I will review the streaming technologies covered in this post and the video. Lastly, we will spend the majority of our time in the actual hands-on demonstration, which mirrors the contents of the blog post. Terminology. Stream processing. According to TechTarget, stream processing is a data management technique that involves ingesting a continuous data stream to quickly analyze, filter, transform, or enhance the data in real time. Once processed, the data is passed off to an application, a data store, or another stream for continued processing. Confluent, a fully managed Apache Kafka market leader, defines stream processing as a software paradigm that ingests, processes, and manages continuous streams of data while they're still in motion. Batch versus stream processing. Again, according to Confluent, batch processing is when the processing and analysis happens on a set of data that has already been stored over a period of time. A batch processing example might include daily retail sales, which are aggregated and tabulated nightly after the store closes. Conversely, stream processing happens as the data flows through a system. This results in analysis and reporting of events as it happens. To use a similar example, instead of nightly batch processing, the streams of sales data are processed, aggregated, and analyzed continuously throughout the day. Sales volumes, buying trends, inventory levels, and marketing program performance are tracked in real time. Bounded versus unbounded data. According to Packet Publishing's book, Learning Apache Apex, bounded data is finite. It has a beginning and an end. Unbounded data is ever-growing, essentially an infinite data set. Batch processing is typically performed on bounded data, whereas stream processing is often performed on unbounded data. Environment setup. Note that the use of the cloud is not required for this demonstration. You might notice that I am using an Amazon EC2 instance on AWS for the demonstration. This is not because the demonstration requires the use of the cloud. It's mainly because my personal laptop is somewhat resource constrained. There's two Docker stacks, and those two stacks can consume a lot of CPU and memory resources. Therefore, I decided to move into an Amazon EC2 instance in order to have some more memory and CPU available for this demonstration to make it a bit faster. But again, the use of the cloud is not required for this demonstration. You can do everything from your local laptop if you choose, as long as you have enough resources. We're going to be deploying and working with two Docker Swarm stacks. Those two Docker Swarm stacks correspond to Part 1 and Part 2 of the two-part blog post. Stack 1, which corresponds to the first part of the blog post, will be installing Kafka, the Kafka UI, Spark, and K-Streams. The second stack includes Kafka, the Kafka UI again, Flink, Pinot, Superset, and Jupyter. We'll be going into how to set these up and install these in your own environment later on in the demonstration. Source code. There are 3 open source GitHub projects that contain all the source code demonstrated in the post and in this video. First, we have the Streaming Sales Generator project. The Streaming Sales Generator project contains the Streaming Synthetic Sales Data Generator, which is a Python script. It also contains the 2 Docker Swarm stacks that we're going to be using. And lastly, it contains the Spark Structured Streaming PySpark scripts, which will be running in the first part of the demonstration. Next, we have the K-Stream Kafka Demo GitHub project. This second project contains the Kafka Streams or K-Streams Java source code. The K-Streams project is written in Java. I've already compiled the Java code and have built a Docker container to run the job for you. You don't have to download this project or compile the Java code if you don't want to, but it is available for you to use and review. Third is the Flink Kafka Demo project. This contains the Apache Flink Java source code. I've already compiled this code similar to the K-Stream projects, and I've included a jar file in the project for you that you can use for that part of the demonstration. The jar file is uploaded into the Flink UI, and we'll demonstrate that a little bit later on. So again, you don't have to compile a Java source code yourself for either the Flink project or the Kafka Streams project if you don't want to. For the Kafka Streams project, there's a Docker file that's going to be part of the Docker Swarm stack we stand up. And for the Flink part of the demonstration, there is a jar file in that project, which you can download and unzip, and then we're going to be uploading that into the Flink UI. So you don't have to compile that code either. I'm now going to quickly review the streaming technologies which are covered in the demonstration, starting with Apache Spark Structured Streaming. Apache Spark Structured Streaming is a scalable, fault-tolerant, open-source stream processing engine built on the Spark SQL engine. You express streaming computations with Apache Spark Structured Streaming on unbounded data the same way that you would express batch computations on static data. Queries are processed using a micro-batch processing engine, which processes data streams as a series of small batches or micro-batches, thereby achieving an end-to-end latencies as low as 100 milliseconds and exactly once fault tolerance guarantees. Next, we have Apache Spark Kafka Streams, aka K-Streams. Kafka Streams, or K-Streams, is an open source client library for building applications and microservices. K-Stream applications are written in Java that perform stream processing and incremental aggregations. Input and output of data are stored in Kafka. K-Streams combines the simplicity of writing and deploying standard Java and Scala applications on the client side with the benefits of Kafka's server-side clustering technologies. Next is Apache Flink. Apache Flink, again, is an open source framework and distributed processing engine for stateful computations over unbounded and bounded data streams. Apache Flink is designed to run on all common cluster environments, perform computations at in-memory speed and at any scale. Apache Flink excels at processing both unbounded and bounded data sets. Flink applications are written in Java, which perform stream processing, incremental aggregation, and multi-stream joins. Next, we have Apache Pinot. Apache Pinot is a real-time distributed OLAP, or online analytical processing data store. Pinot is purpose-built to provide ultra-low latency analytics, even at extremely high throughputs. Pinot ingests directly from streaming data sources, such as Apache Kafka and Amazon Kinesis, and makes those events available for querying instantly. Pinot ingests from batch data sources, such as Hadoop HDFS, Amazon S3, Azure ADLS, and Google Cloud Storage. Lastly, we have Apache Superset. Superset is a modern open-source data exploration and visualization platform. Superset is fast, lightweight, intuitive, and loaded with options that make it easy for users of all skill levels to explore and visualize their data, from simple line charts to highly detailed geospatial charts. Superset can connect to any SQL-based data source using SQL Alchemy. In this video and in the demonstration, we will query and visualize unbounded data streams from Kafka generated by Flink with Apache Pinot, and then visualize those using Superset. In this high-level architectural diagram, you can see a summary of the different technologies which I've covered and the ones that we're going to be demonstrating today. So starting with the streaming data generator, we'll generate synthetic data, which will be written to a series of Kafka topics. We'll then use Apache Spark, Apache Flink, and Kafka Streams to read those Kafka messages and write those back to a second set of Kafka streams. We'll then consume those Kafka streams with Apache Pinot. We'll use OLAP type queries to query that data. And finally, we'll visualize that data using Apache Superset. I'm going to begin the first part of our demonstration. In part one of the demonstration, I'll cover setting up the environment, installing the first Docker Swarm stack, and then we'll get into Apache Spark Structured Streaming and Apache Kafka Streams, or K-Streams. Once we demonstrate those two technologies, we'll move on to part two of the demonstration. I'm going to switch over to iTerm. I've logged into my Amazon EC2 instance. I mentioned before that the cloud is not necessary for this demonstration. The only reason that I'm using an EC2 instance or a VM in the cloud is because my own laptop doesn't have enough memory or CPU to run all the Docker containers in an efficient manner. But again, you don't need the cloud. You can run this entire demo from your own laptop or workstation. The instance I've stood up for the demo is an Amazon EC2 M5 Extra Large instance. It has 4 vCPUs and approximately 16 gigabytes of memory. If we take a look at the directory, I've already downloaded the Streaming Sales Generator project. If you want to download the Streaming Sales Generator project, you can get Clomat to your local instance or to your EC2, depending on how you want to run this project. And I'll just switch into that job and just check the status to make sure I have all the files. I'll stash my changes, and I will just pull down a fresh copy for this. There we go. So I have a fresh copy now of the project and I'm ready to begin. I'm going to go ahead and switch over to PyCharm, which is the IDE that I use in order to edit Python. And I'm going to take a look at the streaming sales generator project. That's the same project that I just get cloned locally. We can take a look at the various files in here. The files that we're most interested in right now are in the Docker subdirectory. We have the Flink Pinot Superset stack, and we have the Spark K-Stream stack. The Spark K-Stream stack is the first stack that we're going to take a look at, and then we're going to go ahead and deploy that. If we take a look here, a couple different containers that are going to be stood up. We're going to stand up a Spark image so we can run our Spark Structured Streaming jobs. We're also going to stand up Kafka, 3.31 of Kafka, and Zookeeper. So we need Zookeeper in order to run Kafka with this version. I also have a K-Streams Docker image. This Docker image is a compiled version of the K-Streams application that I built in Java, and we'll talk about that a little bit later in the demonstration. But for right now, all you need to know is there is a K-Stream image. There's a compiled jar that's been placed into a Docker image on Docker Hub. That image will get pulled down, a container will get built, and this job will execute when it starts. We also have the Kafka UI. The post does have commands. We are going to be using Kafka throughout the demonstration. It has all the keyboard commands. If you want to look at the different Kafka topics and list out the messages, you can use the terminal window. I'm going to be using Kafka UI. It's a little bit easier for the demonstration to take a look at the various topics and the contents of those topics as we move through the demo. Kafka UI is provided by Provectus Labs. You can see the address right here, Provectus Labs Kafka UI. And also just want you to note that that's going to be spun up on port 9080. So 9080. So that's one of the ports that we'll want to make sure that we have access to in order to take a look at the topics and the messages in those Kafka topics once we get our job started. So again, Kafka UI, K-Streams, Kafka and Zookeeper, and Spark. So that's what we're going to be installing. So I'm going to switch back over to my terminal window. I'm in the directory right now, so I'm in the streaming sales directory folder. And we're going to go back to our blog post. And I'm going to follow right along with the blog post. So this is part one of our blog post. And I'm just going to scroll down and get the commands in order to install. So we went ahead and we get cloned the directory already. So I've already cloned that directory down. And if we move down to Docker, we're going to be deploying the first stack. And if we scroll down a little farther, I've listed all the commands. So I've already changed directories into the streaming sales directory. If you're new to this, you shouldn't have anything deployed. I'm going to just take a look and see what I have deployed here and if I have anything deployed. So I do have a stack from the previous demo. I'm going to go ahead and delete that stack. So I don't have any stacks deployed, and we'll just check that too. So those are still being deleted. So it looks like everything's deleted. So all of our containers are now deleted. So I'm going to switch back to the blog post and I'm going to grab this command. This command will deploy our Docker Swarm stack. Now that's going to take a few minutes. It's going to be a little bit faster on mine because I've run this demo a few times and I have the Docker images already installed locally. So those images have already been pulled down to my instance. You can see some of those here. If you're deploying this for the first time, it'll take a few minutes for those images that get pulled down. A few of them are fairly large. It might take a few minutes depending on your bandwidth, and then it'll take a little bit for those containers that get spun up. A number of ways you can take a look at that. You could use Docker stats. You can also use the Docker stack services command, and the streaming stack is the name of the stack. So if you're referencing either stack 1 or stack 2 later in the demo, they're both named streaming stack. So we'll deploy this stack, we'll do part 1 of the demo, we'll then delete this stack and deploy the second stack and do the second part of the demo. So we'll only have one stack running at a time. We can take a look and we can see that the containers are starting to come up. So we have 101 replicas. We still have a couple zeros, which means these are still coming up. The K-Streams application itself will still show 0 of 1 until we start the Python generator script in a moment. So we're going to leave that be for a minute, let all those containers come up. And once we start the synthetic sales generator going, we'll see this container start and it'll start logging changes. So let me clear this out. Next, I'm going to talk a little bit about the streaming synthetic sales data generator. So I'm going to switch back over to my streaming sales generator project on GitHub, and there is a README included, and we'll just go through the README quick. So in a nutshell, the streaming sales generator generates a series of messages to a series of Kafka topics. It simulates, as I said before, a retail smoothie shop. So we have things like products, transactions, and inventory. Each one of those different messages are going to be written into a series of Kafka topics. We'll then be able to use our streaming analytics tools, Spark Structured Streaming, and K-Streams for the first part of the example, and we'll be be able to analyze and aggregate that data that's flowing into Kafka in real time. And then we're going to write that either out to the console in the case of Spark Structured Streaming, just a simple example of reading in that streaming data and writing it back out to the console in an aggregated fashion. And then with K-streams, we'll write it to a new topic. I would suggest reading through the README file for the sales generator. It lists all the different features. It also talks about how to configure it. So to start off with, there is a CSV file that's contained in the project, and it has a list of products. And these are the smoothies which will generate the transactions. So the transactions will be one or more of these smoothies being sold. If we scroll down a little bit, we can take a look at the product. So these are the types of messages that I'll expect to see in the product topic, and we'll take a look at that in the Kafka UI in a few minutes. We have the event time that the message was created. We have the product, the category of the product, the name of the product, the size of the product, the cost of the product, so cost of goods sold, retail price. We also have an inventory level, and as transactions are generated, the inventory goes down. When the inventory hits a certain level, the sales generator script will renew that inventory, will increase the inventory back up to 25 units. And that will also generate a message. So in addition to product messages, so a list of all the products as messages in a topic, we'll also have restocking messages. So as the inventory is depleted and the inventory is renewed, we'll get messages for those types of activities too. So we'll have plenty of data to take a look at and aggregate. We also have whether or not it contains fruits, vegetables, nuts, whether or not it's caffeinated. The propensity to buy is something you don't necessarily have to worry about right now. I use this number in order to determine how many of each unit I'm going to sell. Certain products are sold more often than other products. So if you look at the counts of certain products, you'll notice that some of those appear to be more popular than others. Instead of just generating an even number of all products over time, I'm using this propensity to buy, which determines how many of those products are sold or the frequency at which the random sales generator picks that product over another product. Something you really don't have to worry about right now. As we get a little farther into this, you'll definitely see that there's certain trends evolving in terms of which categories are sold more often than other ones. Which ones have fruit or vegetables or nuts or caffeine may or may not be sold more frequently than other ones. So try to build in some different patterns. So if you're going to do any further analysis on this, you can pick up on some of those. Now we see a purchase topic. So we see the type of messages that will land in our purchase topic in Kafka. These represent individual purchases. So we can see we have a transaction time. We also have a transaction ID. The transaction ID is important because an individual transaction, you can imagine going into your local smoothie shop, you might order one or more smoothies, and you may order one or more of each type of smoothie. So I might order 2 of CS01 and I might order 3 of CS05, for example, or SC04. So a transaction can contain multiple products. Therefore, it will have multiple messages, and those messages can be aggregated based on the transaction ID. Again, there's a product ID, which corresponds to the product. There is a retail price. There is the quantity sold. The reason we have the price is because the prices may change over time. So I want to be able to record the price so that I can look at sales over time and price trends over time. We also have the concept of a member. So the sales generator project randomly chooses whether or not the person who purchased the smoothies is a member. And what that means, if you're a member, you get a discount. So at random, a purchase may or may not be determined to be by a member. If it's by a member, they'll get a particular discount. And we see that down here. So in this case, they got a 10% discount for purchasing the smoothies. You also have the choice whether or not to add a supplement. And again, that's random and it is weighted, just like the types of smoothies that are sold. Whether or not your member is weighted, whether or not you choose a supplement is weighted. If you choose a supplement, there's also a supplement price. And because that can change over time, we also want to record that. And then we have the total price. So $4.99 times 1. They're not a member, so there is no discount. We add in $1.99 for a supplement. So those are the types of transactions that I expect to see. We also have restocking activities. So as the inventory drops below a certain number, which is configurable, almost everything that is part of the sales generator is configurable. The frequency of transactions, the number of transactions, the cost of supplements, the weighting, whether or not you're a member, the weighting, whether or not you want to add a supplement, all those types of things are configurable, and I'll talk about that in a moment. So we see the restocking activities, existing level. So in this case, if we go below 10, we add 15, and we end up with approximately 25 for all of these restocking activities. You'll see a fairly consistent number. So I would suggest reading through the entire document here for the sales generator if you want to learn more. Lists all the features, lists how to use it, and also at the bottom there is a to-do list. So there's a number of other items that I intend on adding into the sales generator. But for right now, these are the features that it has. Again, we're going to be seeing a topic with messages, a topic with transactions, and a topic with restocking activities. So we're going to switch back over to the terminal window. So we're logged into our instance. And again, I'm just in the directory for the streaming sales generator project, which I cloned from GitHub. And we want to start the sales generator. So I'm going to go back here, and if we look at the blog post, all those commands should be in the blog post. If we scroll down a little bit, I'm talking about the configuration in a moment. We have the commands here. So if this is the first time you're using it, you'll want to install Kafka Python so that we can connect to our Kafka instance, which is running locally from Python. That's the only package you need to install, and you only need to do it one time. And then you have the choice of running the generator, which is this producer.py Python file in the foreground, but I suggest you run it in the background because we don't want to tie up a terminal window. And ideally, this thing will run for the length of our demo. So we may generate 1,000 transactions. Maybe we want to generate 10,000 transactions or even 100,000 transactions, depending on how long we want to run our demo for. So you'll want to run that in the background so you don't have to open a second window. And then we can use the PS with the -u flag in order to make sure that that process started in the background properly. So this is the command we're going to want eventually. The first thing I'm going to do though is I'm going to go back to the window here, and I want to just take a look at the configuration file, and I'll show you what that looks like. So that's in the configuration directory, and it's configuration.ini. And this is the file, and I want to just change a couple of values here quickly. What I'll do, though, let me switch back over to GitHub for a moment. It's probably a little bit easier to take a look at. So again, back in the Streaming Sales Generator project, I'll go into the configuration folder. The generator is actually a series of Python files and one INI file. The main one, which we will actually start as a process, is the producer PY, but the other important file is this configuration INI. I put hopefully a helpful remark in here that explains what each one of these are. It's broken down by Kafka, so configuring Kafka, whether you're using plain text or Sassel Scram, those are the two connection methods that are included with the sales generator right now. Again, you'll see the topics here. So these are the name of the topics we're going to generate. A little further down, we have sales. How frequent in terms of seconds that a sale is generated? So you can think in a typical retail shop, maybe you get a new customer every couple minutes. In order to speed this up, though, we'll probably want to set that lower. So in this case, the minimum frequency at which a sale can occur is 2 seconds. So at minimum, we'll get a sale every 2 seconds. And at worst, or the maximum value, will every 5 seconds. So somewhere between every 2 and 5 seconds, in this case, the defaults will make a transaction. So a transaction will be logged. And the other key number is the number of sales. So the number of sales or transactions used interchangeably here in the post in the video, is the total number of transactions that we want to create. And again, a transaction can contain more than one item for sale. So we may have sold one or more items as part of that transaction. So this 1,000 could translate into 1,000, 1,100, 1,200, 1,500 total transactions because we use a transaction ID and then each message contains a particular product which was sold, an account, and a price. You can read through the rest of these. It's all configurable. We also have the inventory. So I mentioned when the inventory hits 10, we add 15. Those are defaults. You can change that too. So how often things are restocked and the quantity that are restocked. So again, I'd recommend taking a look at all these. The important ones we want to look at are these three. So minimum sales frequency, maximum sales frequency, and the number of sales. That's what's really going to control how many transactions we generate and how long the script will run. And ideally, we want it to run for a while as we do this demo. So I'm going to come back here. I'm going to scroll down. The only thing I'm going to change is the number of sales. So 1,000 will go pretty quick, between 2 and 5 seconds. Let's just do 10,000 for now. So that should run long enough for part 1 of this demonstration. And then for part 2, we'll start all over again and we'll deploy the new stack. But for part 1 of the demonstration, we'll generate 10,000 transactions. That should be enough to get through the demonstration. We'll save that, and then we want to go back to our blog post. Let me just grab that command. So we're going to run the producer.py, which is the main sales generator Python script, and we want to run that in the background. So I'll switch back and start that, and we can use, again, the PS to take a look at that process running in the background. And we see it right here. So we see that the producer PY is running as a background process, and that will just continue to run. If you remember the services command that I ran before, let's just run that again. And you recall that the K-Streams container was 0 of 1, so it hadn't started yet. As soon as we started generating messages, this started up. So once the sales generator starts and we're generating messages, we're generating synthetic transactions, all of these should now be running. So we have our Kafka container, we have our Zookeeper container, so Kafka and Zookeeper go together. We have 2 Spark containers, so this is what's required to minimally run Spark. We have the K-Streams application, which I'll talk about in a little while, and then we have the Kafka UI, and that's what we're going to use to take a look at what the sales generator is doing right now. And again, that's running on port 9080, so we want to keep that in mind. So I'm going to switch back over, and we're going to take a look at the Kafka UI now. I've set up my firewall so that only I can access this EC2 instance, and I've opened up all the ports that I needed. And I've only opened those ports to my IP address. So ideally, only I should be able to get into this, and therefore it should be secure. Try the right IP address, and that should work a lot better. Here we go. So again, this is the UI for Apache Kafka. It's an open source project available on GitHub from Provectus Labs. It's installed as part of the first stack. A few things to highlight. First, brokers. Since we're just running this for a demo, think of it as a dev environment. We only have a single broker. We're not worried about running multiple brokers, about high availability, about worrying about things like replication with Kafka. This is just a demo. We're running it on either our local environment or on a small EC2 instance. We don't want to take up a lot of memory. And as soon as this part of the demo is done, we're going to delete everything. So no sense in standing up a production grade Kafka instance and spending more time or taking up more resources or potentially spending more money. So we have a single broker that's running. If we go to topics, we see quite a few topics here, and let me explain what these topics are. We see products and purchases. What we don't see yet is inventory. There hasn't been enough transactions yet to hit a minimum inventory level in order to create a restocking event, and the restocking event then generates a message in a demos.inventory topic. You also notice the last three topics, so demo.running.totals, and then we have two KStream topics. This is because the KStream application is running, and that's okay. We're going to take a look at the KStream application after we take a look at the Apache Spark Structured Streaming applications. Let me show you though quickly. So we talked about the products and the purchases. We took a look at the README file, which showed you what those messages look like. We can also do that in here. So I went into the demo.products topic. I'll switch over to messages, and you can see all these messages generated, and you can sort those oldest first, newest first, or live. There's only so many products. So unless the product is changed, once those products were generated, they're all written to the Kafka topic. We have 27 products, so offset of 0 through 26. We can take a look at any one of those. This should look just like the README that I showed you. So we have an event time. Now this is when this message was created. That really has no significance from a product perspective unless we were updating these products and wanted to track changes, then the event time might be relevant. So we have the product ID, in this case IS04. We have a category, so these are indulgent smoothies. And then the item is actually the name of the smoothie. So in this case, Mocha Madness. It's 24 ounces in size. The cost of goods sold is $2.20. The retail price is $5.49. The current inventory level is 60. As we sell more and more products and we hit that low level of 10, it'll restock 15 more. And then every time it hits 10, it'll go back up to 25. We can also see things like, does it contain fruits, vegetables, nuts, caffeine, etc. Let me switch back to topics and I'll show you the transactions, purchases, transactions, or sales. Use that kind of interchangeably in the demo. If we take a look at messages, this would be dynamic. And I noticed they do have this live mode, which is new, but it was a little slow when I brought up products. So I'm going to just stay away from that for now. But we can go to newest first, and we can see that we have 156 messages. And ideally, if I just refresh this, so you can see 161, 162, 163. So remember, every 2 to 5 seconds, we will create a new transaction, which will generate more messages in here. So the sales generator script is running. It wrote all the products to the products topic, and now it's writing transactions. So between 2 and 5 seconds, which is what we use as the defaults, it's creating a new transaction, and those individual products are getting written in here. If we take a look at one of these, we can see that we have a transaction ID ending in 925. That was for a product CS06. Now, we don't know the name of the product or the classification. We're going to be doing a join later with Spark Structured Streaming, with KStreams, and also with Flink in order to join the products topic and the purchases topic to take a look at it so that we can see a more richer view of each one of our transactions and actually be able to tell what CS06 is. But we can see the price. We can see here that we sold 2 of those. Remember I said a purchase could be 1 or more of any item. So in this case, this transaction had CS06. They bought 2 of them at $4.99. They were also members, so they got a 10% discount. In this case, they chose not to add a supplement. So the final purchase was $8.98. Now, there could have been some other types of Frosties sold as part of this transaction. We might expect to see more than one transaction ID in our message. And this is not a unique identifier. So this is a unique identifier for the transaction. It is not a unique identifier for the message itself. And again, we see just more messages. So as the script is running, and I'll just renew this once more, 163, we see we have 199, so about 200 now. So that script's been running a few minutes while I've been talking. It's generating sales, and we see that those are going into the purchases. If I go back to topics, we probably see some inventory now. So we don't see any inventory yet. So it hasn't been running long enough probably, but we'll see that a little later. So we'll start by talking about the first of our 5 technologies, Spark Structured Streaming. So I'm going to switch back over to the project here for a moment, the streaming sales generator. So this streaming sales generator, in addition to having the sales generator, I also added the Apache Spark examples in here. These are written in Python. If you're familiar with Spark, you can write in Scala or Python. Python actually uses PySpark. So these are written in Python using the PySpark extensions or libraries. And we have 3 of them in here. So you can see we have a README and requirements file, and we have 3 scripts or 3 jobs we're going to run. We're just going to talk about the first 2. If you read the post, there is an option with the streaming one. We can do some streaming, or we can also look at a running total. In the first example, we're going to be actually looking at a running total by product. We could also look at a running total aggregate for all of our sales over the course of the day if we want to know how much we sold in total. Both of these are the same. They're just doing a slightly different aggregation. We're going to look at the batch script first, and then we're going to be looking at streaming script. We're going to run these locally. You remember that we have 2 containers that are stood up to run Spark. We're going to be able to run these in the Spark container. If we switch back over to the post for a minute, we'll see that we have all the commands that we need. If I scroll down here a little bit, so we went through Kafka UI. So preparing Spark. So these are the commands that we're going to want to use to run our Spark job. So I'm just going to grab a couple of these lines and just do them one at a time. So the first thing I'm going to do is exec into the container. So I'm going to set a value that is our container name, and then I'm going to execute into that container so I can run some commands. We're going to log into this container. We're going to make sure that it's up to date. The default Spark container, which we're using, is lacking a few packages that we need to install. So we're going to download those dependencies and install those dependencies, those jar files, before we can run our Spark jobs. So let me grab these commands to start. I'll switch back over to the terminal. Let's clear this out. And again, I'm just in the streaming sales generator directory. So I'm in the root of the directory. So you can see now that I'm in the container. Spark container is running, and I'm going to run some commands. So the first thing we can do is we can just update and make sure that we're up to date. We have all the latest packages that we need, just as good practice. So we've done that. And now I'm going to install 4 jar files. So let me do that, and then I'll show you what we're going to do with those. So that was pretty quick. So we actually downloaded, you can see them here. There's a series of jar files that we downloaded, 1, 2, 3, and 4. And then the last step here, in order to get ready to run our Spark jobs, is we're just going to move those into the correct directory, into the Spark jars directory. By moving those into that directory, they'll be available when we execute our PySpark jobs. We'll be able to reference those dependencies, and Spark will know where to find those jar files that we're referencing. So we just move those. If I just list that directory, you can see they're gone now. And then we can just go ahead and exit this container. So I'm back out now to my streaming sales generator directory on my EC2 instance, or in your case, back on your local host. So let me just clear this. So we're ready to run our Spark jobs now. So I'm going to go back to the blog post just to make sure we have all the right commands for everybody. In the Apache Spark examples, there's a few Spark jobs. Let me switch back over to the project and show you what these are before I go ahead and copy them in and start them running. So you'll notice there's an Apache Spark examples, which I showed you before. I mentioned there's a few scripts in here. Let me just show you the first one we're going to run. So this is the PySpark batch job. So the difference between this and the streaming script is this is going to read the contents of the Kafka topic, of the purchases topic. Even though the data is streaming into that topic, it's just going to read at one time. At whatever point I start that job, it's going to grab all of the messages from that topic, and it's going to aggregate them. And I'll show you what that looks like in a minute. Versus the streaming one, which would continually, in a micro batch, if you remember that word that we talked about in the introduction, the streaming job will do micro batches. It will continually update the aggregations or the totals for each product, how many we sold and what's the total value per product. That's in the streaming example. This is in the batch example. So just so you understand, if you remember, we talked about batch versus streaming or bounded versus unbounded. We're going to use the unbounded topic, but we're going to run a batch job on it. So it's just a one-time point in time. Whenever we run it, we're going to get an aggregate for the messages that were available that represent the total sales that were in that topic at that time. So you can see here we have a main method. We have a method which is going to read from Kafka. So this is going to read all the messages from our Kafka topic, and we've set all those up as variables. We read that topic, we read all the contents. We have the schema here. So this is the schema. If you remember when we looked at the Kafka UI and we looked at the purchases and we looked at some of the messages, those messages had a schema: transaction time, transaction ID, product ID, price, quantity. If we come back over and we look at the batch PySpark job, we'll see that same schema here. So we're going to read in all the messages, and we need to know what the schema of those messages are. In this case, we're just going to explicitly define that schema, and we're going to read these messages in and use this schema to define those messages that we read in. We're then going to do some simple aggregations. You can see here we have our data frame. We're going to select a particular set of columns from the messages from these schemas. we're going to total some of those. So the total quantity that we sell. So for any given product, we want to know how many we sold and what were the total sales by product. I'm also going to limit that to the number of rows of 25. So this is going to aggregate each individual product. So you remember we had about 27 products. If we've sold at least one of every product, we would have 27 rows of data. I'm going to sort those by the greatest quantity sold, and then I'm only going to look at the top 25. So that's the type of analytics function we're going to run on this using PySpark. Let me go back over to our post and get the commands. We'll switch back over here. So I ran this command, and this is simply copy the contents of that Apache Spark example subdirectory into the home directory of our container. So now those Spark jobs are in that container where we installed those 4 jar files. I'm going to switch back over, and I'm going to actually execute back into that container. So we're back into there now. Scroll down here a little bit. I want to set a few values. So remember the PySpark job when we were looking at it had a few variables. So we had a variable for the Bootstrap servers. We had a variable for the topic that we wanted to read from. You can see that in the blog post we defined those. So our Bootstrap is Kafka. That's the name of our container, the Kafka container. 29092 is the port, which we've made available on that container to read the messages from. So let me set those 2 variables. So again, I'm in the container. I just set 2 environment variables. Let me go into the home directory. So remember we copied the Spark jobs from our local, or in my case, my EC2 instance, into the container, into the home directory. And if we list that out, there's our job. So I copied the whole folder, and we really didn't need to read me the requirements. That's fine. But I copied all those jobs in. So let's go ahead and run this first job. And what I would expect to happen is this job's going to start up. It's going to read all the messages from Kafka, and it's going to aggregate those messages. So total quantity, total sales by product, sort them from highest to lowest sales, and then take the first 25 rows and output those. And we can see that we got exactly what we expected. Product ID, sales, and quantity, and they're sorted from highest to lowest. For the product ID of CS08, $334.81 at the point in time which we ran the batch job. Now, if we were to run the job again, these numbers would change because we've generated more sales. But at the point in time which we ran this job, CS08, $334.81, and we sold a total of 48 of those. And you can see that decreases down to CS06, just 11. So that's PySpark. That's a batch job. So we ran a batch job against a Kafka topic and aggregated the totals and wrote those out to the console. So we didn't write those out to a new topic. We didn't send these to a database. As we move into K-streams, we'll be creating a new topic and we'll be writing the aggregations back to a new topic. They'll be a little more interesting than just a running total. So we'll write those back. But to start off with Apache Spark Structured Streaming, we're just writing to the console. So what's the difference between batch and streaming, and how does that output differ? Let's go back, and we're going to run the streaming job now. So let's switch back over to GitHub for a minute, and I just want to open that file and show you the difference. It's going to look very similar to the first job we ran. So this is the Spark Streaming Kafka.py file. This is our Spark Structured Streaming job. The main difference here, if you're familiar with Spark, is if we get down to the read. So here we're reading from Kafka, and you'll notice here that instead of a Spark read, which is typically what you would do, Spark read Kafka, Spark read a CSV file, an XML file, we're going to be doing Spark read stream, and that's what's going to keep this job running. So this is a Spark Structured Streaming job, which means it won't stop until you stop it, and that's something to keep in mind, right? You don't want to forget about this. Now, ideally, if you have streaming data and that data is continuously streaming, you wouldn't want to stop that job. But in this case, we'll let it run for a little while, and then we'll stop and we'll take a look at the results. So again, we're doing a Spark read stream. Similar, right? Configuration is similar. Reading from Kafka, reading from a topic, defining our Bootstrap servers. We're explicitly stating our schema for the messages. The message schema, this is exactly the same as the batch job, right? Same schema, same messages, same topic. We're just going to be reading those continuously in what's referred to as micro batches and continuously updating those totals. We're going to be writing out the top 10 rows. So just for expediency and so we can view a couple different batches, I just made the output a little smaller. It will aggregate all 27 products. It'll just output the top 10 sales, and it'll be doing that on a regular basis. It will be outputting those total sales. So I expect to see that. The window size here, if you're familiar, I won't go too deep into this. We could spend quite a bit of time talking about exactly how Spark Structured Streaming works, windowing and aggregation functions, watermarks, group by, those type of things. Basically, we have a 10-minute window, and we're outputting those every minute to the console. So the trigger time, the processing time is 1 minute. We're taking a look at totals over the course of 10 minutes. starting that account over again. So you could imagine if you had daily sales, maybe you want to keep track of sales and you want to know where you are at every hour. What's my total sales at lunch? What's my total sales at dinner? What's my total sales for breakfast? Those type of things. So you can change these numbers. You could look at this over the course of a day, a week. You could look at it over the course of an hour. We're just randomly taking 10 minutes with a 5-minute overlap. And every minute I kind of want an update. So I want to know every minute where my sales are for that 10-minute window. So that's the streaming job. Let me switch back over. We'll grab that command. So same command, just calling a different file. We've already set our environment variables, so we shouldn't have to set those again. And we're going to run that. So we're going to call the Spark submit on the Spark streaming Kafka.py file. So the streaming PySpark job. We'll let that run and get started. Now, what I would expect to see, again, every minute, I'm going to see a micro batch or a batch of the top 10 sales sorted by highest sales first. And that will continue every minute. And then every 10 minutes, that cycle will begin again. So let's get a batch or two here, and then we'll take a look and see what the output looks like. Let me scroll up here. Here's our first batch, and you can see here batch 0, and we can see that we have some initial sales. We see here that we have SC04, we've sold 5 of those, CS07, 8, and so forth. So these are the top 10 sales that were done during this moment in time, and we can find out a little more stats about that. There's a total of 729 rows, how many messages it read, the average min and max, time that it took, the watermark, etc. So we can see some information about this batch. Now, if we just let this continue, I would expect to see a batch 1, batch 2, a batch 3, and this will just run continuously, and it would continue to aggregate the messages and output that to the console. So there's another batch. So here's batch 1. So a minute went by, batch 0 was written, a minute went by, batch 1 was written. It'll continue to write. So we can see here now that for batch 1, SC04, there's 6 of those sold. So if we look back at the other one, there's more sales for these top 10 items. And that will just continue to go on for the next few batches. So again, that's a micro batch. Again, we'll just go a little bit forward in time here. So there's another batch. Batch 2, so we had batch 0, batch 1, batch 2. Again, we see SC04, it's now up to 7. We see IS01, it's now up to 12. Now, this is sorted by sale, so even though we only have 7 of these, they're more expensive. SC04 is obviously more expensive than IS01. We can also see here the time period that we're looking at. So we're looking between, in this case, 2 a.m. and 2:10 a.m. So again, this will just continue. I'm going to go ahead and just stop this job and kill it since this is just a demonstration. If the sales generator is still going and hasn't generated 10,000 transactions yet, which is a number that we set, this will just continue to run. Also note here, if you remember, the batch that I showed you previously was, I believe, 2 a.m. to 2:10 a.m. This is now 2:05 a.m. till 2:15 a.m. So it's a 10-minute window and it's a 5-minute slide. So it's 10 minutes, slides 5 minutes. You can see that continuing here. So that's Apache Spark Structured Streaming. We demonstrated a batch job and a streaming job. Now we're going to move on to K-streams. We're going to finish the first part of our demonstration by talking about our second streaming technology, Apache Kafka Streams. First off, let's go over to GitHub, and I've opened the project. So if you recall, there's 3 GitHub projects which are part of this demonstration. Now, you don't need to download this project. You can modify it, you can recompile it, you could build your own Docker container. I've already done all of that for you. So for the sake of this demo, we're just going to show you the contents of this GitHub repository. But again, you don't actually have to download this or compile the code yourself if you don't want to. We already have a container that's running with this job running in it, which we installed as part of the Docker Swarm stack. So the K-streams demo is written in Java. It's available on GitHub. And I just want to call out a few things. And probably the easiest way to do that is to use IntelliJ. Before I do that, let me just show you the README. So there is a README file, talks a little bit about the generator. There's a little video demonstration if you want to see it actually running. And as I get into the demo, I'll show you a little bit more about what it does. You remember the topic that contains our sales transactions? We're going to read that in, so that's our source. And then our sink or our output is going to be an aggregation of these messages, similar to what we did with Apache Spark Structured Streaming. We're going to aggregate, in this case, we're going to do it by product again, just like we did with Spark. We're going to aggregate the total number of transactions, the total quantity sold, and the total sales for each one of the products products, and we're going to continuously stream that. So again, this is a streaming library, streaming technology. We're going to use Kafka Streams to stream that information to a new topic. So this is what those messages are going to look like. We'll take a look at that in Kafka UI, which will make it a little easier to see. So all the instructions are here. Again, you don't have to compile it. If you choose to compile it, you can. This has all the instructions. It also has the Docker file. If you want to recompile it yourself and create your own Docker file, you can do that. I've included all of that in the project. So let's switch over to IntelliJ. That's the IDE that I happen to be using. Two things. This project is built with Gradle. You could use Ant, you could use Maven. I've decided to use Gradle, so I build my projects with Gradle. And let's look at the build.gradle file first just to see the dependency. So we can see the Kafka Streams dependency here. We're using 3.2.1. I built this about a month or so ago. 3.2.1 was the latest one. We also have a dependency on Kafka. We're going to be reading Kafka using Java, so we want that dependency also installed. Using a few other ones, Jackson binding, JSON for our models. We'll take a look at our models in a minute, and our custom serializer, deserializer for our Kafka messages, which we're going to deserialize from JSON, which is what the body of the message is in, and serialize those into a Java object, into a POJO, an instantiation of a model class, and then eventually we're going to want to serialize those back into JSON and write those back to Kafka to our new topic. So we need a custom serializer, deserializer that can read and write our purchases, and we'll take a look at those in a moment. Our main code is in our source directory. There are no unit tests in this, so it's a pretty basic project. You're welcome to go in and write your own unit tests. I may do that later, but for now, the source code is under source main. We have a main class, just like our PySpark demo. We need to define where our Bootstrap server is now. I could have used a configuration file for this. I could have injected the configuration. For the sake of this demo, I kept the project pretty simple. I've hard-coded the Kafka servers. This is going to be the consumer ID and the input and the output topic. So we're going to read from demo.purchases, and we're going to write our aggregated results to demo.running.totals. So that's we'll expect to see that when we go to our Kafka UI. The aggregation part of this class is right here. So we're reading the messages in, and again, I'll talk a little bit about it in a minute. We have a custom serializer and deserializer to read in the Kafka messages, which are in JSON, deserialize those into Java objects. We're going to perform aggregations on those Java objects using Kafka Streams. We're then going to serialize those back to JSON and write those to Kafka. So that's all taken care of with this project. Here you can see the total transactions, the total quantities, and the total sales. So those are our three aggregations. And then we're going to write those back out to our output topic. So pretty straightforward, not too much code there. Kafka Streams is pretty powerful. It has some powerful windowing and aggregation functions. It makes it pretty easy, or at least you don't have to generate a lot of code in order to perform aggregations on your streaming data. We also have the serializer classes, and we have our model classes. So our model classes are POJOs. We have a purchase. This represents the purchases topic. So this is our input topic, and we've defined each one of the fields. And I've also indicated the name in the JSON body. So what the key value is for the key value pair in the JSON object, the message body from Kafka, and then what we're going to deserialize that to. So for the Java object, that is all defined here. We've also defined integer, big decimal, string, etc. We are using Lombok. Lombok just allows us to write a little bit less code for our POJOs. We don't have to define all of our constructors. This will take care of it for us. So we have the purchase, which represents the objects which are being read in from the purchases topic. That's our input or our source topic. And then we have total, which represents the objects that we're going to serialize into JSON and write to our output topic or our sync. Again, this has the event time, the product ID, since we're aggregating by product, the total number of transactions, the total quantity sold, at the time in which we write this message to Kafka. This POJO represents the objects which are going to be serializing the JSON and writing to Kafka. We have our POJO deserializer and our POJO serializer and our custom serde for our purchase object and for our total object, and those are represented by our models here. So serializing, deserializing, in this case, deserializing the purchase and serializing the total, and those are all defined in these classes. So pretty straightforward. If you've worked with Apache Kafka Streams before, this will look pretty familiar. So that is our project. Like I said, I've already taken this, I've compiled it into a jar, an Uber jar in this case, and have created a Docker file. That Docker file contains that Uber jar, and it will start up and it'll start consuming as soon as that stack was started, so it should be running. So let's switch back over for a moment and we'll take a look at our article. So if we scroll down here to demonstration 2 in part 1, Apache Kafka Streams, and I just want to go down here, this talks a little bit about the aggregations, give you a little more detail. If you wanted to run that locally, you could, and here's all the instructions. This is also good good to test it and make sure it's working. But we've already built a container. I've used OpenJDK 17 in Gradle. So we have the OpenJDK 17 container. We've copied in the jar file, and then we have a command to start that going. We're going to be consuming from the demo.purchases. That's our source topic. And we're going to be writing back out to the running totals topic, which is our sync topic. The job's already running. We can view the results of that job in the Kafka UI. I'm just going to grab this and we're going to follow along with the logs. So I've gone back over to my EC2. The one thing I want to check is that my generator is still running because we've been doing this demo for a while. So it is still going. So you remember we did 10,000 transactions somewhere between 2 and 5 seconds. It's going to write a transaction. It's going to do 10,000 of those. So we'll let that keep running. We don't have to start it again. Now, if it did stop, simply start it again. You could increase that number if it didn't run long enough. Just make sure it's running before you do each part of this demo. And again, let's just take a look at our stack. So here's our containers. You can see that this is the streaming stack K-Streams. This is the name of the container that we're going to be taking a look at the log, make sure that our application is running correctly. And this is the container here. So this is on GitHub. So when I created this Docker Swarm stack, it pulled this image down from Docker Hub from my Docker Hub account. That's the Docker image which I created and placed the Uber jar into. I pushed that to Docker Hub, defined that in my Swarm stack YAML file. When I stood up the stack, it pulled this image down and created a container from it. And it started immediately reading from the Kafka topics from the sales generator, aggregating the results and writing that back to a new topic. And we'll take a look at that topic in a minute. Go back here and grab this command. So this should follow the logs, and we can see that it is reading the messages. So the reason that it cycled through that's been running for a while, so the log just caught up. This has been reading since the beginning, since the stack was started and since the sales generator was started. It's been aggregating those results and writing those to a new Kafka topic. And we can see here every few seconds it writes a new message to the new topic. We can take a look. We can see the transaction ID, the product, the price, the quantity. So it's reading in those purchases and it's going to be aggregating those totals and writing those totals out. So there's actually two types of events. There's the purchase event, which comes from the purchase topic, and then that's deserialized into a purchase object. And then there's the total object, which represents, remember we had the total and the purchase models. This is the total object, and this has been serialized to JSON and written to the Kafka topic. I'm just outputting both of those. And this is just purely informational to the log so that you can see what's going on. We can see that this is working. Reading in purchases, writing out totals. Reading from one topic, writing to another, source and sync. So while that's running, let's switch over to the UI, the Kafka UI for a moment. We'll go to topics. We can see here that we do have a demo.running.totals topic. So if I take a look at that, we can see that we have 1,733 messages. So that's been running for a while. It's aggregated. Let's actually go back to topics for a minute. Let's go back to purchases and see how many purchases there's been. 1,740 messages have been written to this topic. If we go back to topics, we'll go back to running totals. So there's an equivalent number of messages that have been written to the new running totals topic. And we take a look at one of these messages. We see the model. So we have the event time, the product ID, transactions, quantities, and sales. For CS09, there was one transaction, quantity of 1, sales of 628. Now this was the first value. If I sort these by newest first, we should see some higher totals. So that was the very first transaction. Let's look at the very last transaction. This is for product ID SF07. To date, we've sold total of 111 for total sales of $762.30. And if we just refresh that, so 1761, 1774, 1775, 1776. So we can see that it is truly streaming. So the data is streaming into our source topic. K-Streams has been running continuously since this demo started, since I stood the stack up. It's been aggregating the totals. The new message hits the source topic. K-Streams application picks that up, aggregates that along with the existing totals, and writes that message out to Kafka. So we have 1,776 messages in that stream. So that's K-Stream. K-Stream is running and doing what we expected it to do. So that's the end of the first part of our demonstration. We covered setting up the environment. We stood up the first Docker Swarm stack. We then took a look at the streaming sales generator. We then took a look at both a batch and a streaming Apache Spark Structured Streaming job, one batch job and one streaming job. And finally, we looked at Apache Kafka Streams or K-Streams. We took a look at the job application I wrote, and we took a look at it running in Docker. We're going to be using Kafka, Zookeeper, the Kafka UI. In part 2, we're going to be switching out Apache Spark Structured Streaming and Apache Spark Kafka Streams for Apache Flink, Apache Pinot, and Superset. So we'll be taking a look at those 3 technologies in the second part of this post.